So today topic is 13th group elements. So in 13 group elements we have boron, aluminum, gallium, indium, thallium. Okay, so questions mainly comes on the boron, sometimes on aluminum also. So but this group is very important. So there are two effects: alternation effect and then we have inert pair effect. So as we know that down the group size will increase, so because of that electronegativity should decrease, right? If we see the electronegativity means what we are expecting here, electronegativity, boron should be more than aluminum, then gallium, indium, thallium, because electronegativity is inversely proportional to the size. Okay, but if we see the experimentally, the electronegativity will be like this: boron, thallium, indium, gallium, and aluminum. So this is the electronegativity order. So why it's not means in other cases except in boron and carbon family, even in carbon family also carbon is greater than germanium, then silicon comes, means silicon comes at last, I think. Carbon, silicon, germanium, other two elements comes, silicon comes at last. So why this alternation effect? So this, the reason for this is alternation effect. So what is the alternation effect? So here we have a 2p orbital, 3p, 4p, 5p, 6p. So this is the first, we'll talk about the 4p. This is the 4p orbital. Okay, so 4p orbital is surrounded by the 3d orbital, right? So there is a pore shielding from the 3d orbital on the 4p orbital. So because of pore shielding, the nucleus can means if anything like 3d comes here and here 4p comes. So there is a pore shielding of 3d on the 4p orbital. So because of that, 4p orbital is having more effective nuclear charge. So what is the electronegativity? Electronegativity means a tendency to attract the electrons. If nucleus is if nuclear charge is more, it's tend to attract the electrons faster. So like that, because of electron effective nuclear charge is increasing, so down the group effective nuclear charge will increases. So thallium is having more effective nuclear charge than indium, then gallium. This is because of the alternation effect. So because of that reason, the electronegativity of thallium is greater than indium, then gallium, then aluminum, and here boron comes. So this is the alternation effect. Then inert pair effect. So we know that in boron family we have a ns2 np1. So 3 valence electrons are there. That means the maximum electron oxidation state it shows is +3. But down the group, +1 is stable compared to +3. So thallium is stable in +1 compared to +3. So this is because of the inert pair effect. So now we'll go for the borons. So borons classification is very important. So we have we have classified the borons into 5 classes: closo, nido, arachno, hypo, and clado. So any borons which is having a Bn Hn plus 2 molecular formula, that comes under closo. Then Bn Hn plus 4 comes under nido, Bn Hn plus 6 arachno, Bn Hn plus 8 hypo, Bn Hn plus 10, this is comes under clado. If you take diborane is a B2H6. So here see, here N means number of borons, right? So here B, N means 2, H means here N indicates number of borons, N equals to number of borons. So now in B2H6 how many borons? 2. plus 4. So this comes under Bn Hn plus 4. So because of that reason, this is the nido configuration. So this is a classification about the boranes. So this they will in examination point of view, this is very important. And next we have a STYX number. This is also important. So S means number of BHP bonds. Okay. Next T means number of BBB bonds. Y means number of BB bonds. X means number of BH2 bonds. So this is about the STYX number. So if you want to if you don't know the structure, so let's say, so you know the structure of B2H6, right? For this calculation, this STYX number is very simple, like, because we know that how many BHP bonds are there? 1 2 STYX, this is 2. And next T is BBB bond, there is no BBB bonds, 0. And Y means BB bonds, there is no BB bonds, then this also 0. And X means BH2 bonds, so there are 2 BH2 bonds, this is 1, this is 2. So this is the STYX number for the diboranes. And when we'll talk about the other higher boranes like B4 H10 and B5 H11, B6 H10, B10 H14, B5 H9. So when we are talking about these boranes, these structures are a little bit complicated to remember. So for that I will tell one like the way how to calculate the STYX number without knowing the structures. So that will be helpful because even if you learn structure also, you may forget after some time. So it's better to follow this method. So first we will take B4 H10. So what you need to do first, so there are 4 steps are there. Step 1, just take the difference between the number of boranes and hydrogens. So difference between the number of boranes and hydrogen, this is step 1. So what is the difference? Number of boranes are 4 here. Okay, so number of boranes and number of hydrogens. So number of hydrogens are 10 here, minus number of boranes are 4. Just take this reversal. Okay, so difference is 6. Okay, now step 2. If the number of boranes are even, number of boranes is equals to even, and whatever the difference comes between the in the step 1, that we have to divide into 2 even numbers. If number of boranes are odd, then difference we have to divide into 2 odd numbers. Okay, so now we have B4 H10, the difference is 10. So now the difference we have to split into 2 even numbers, because the number of boranes are here even. So 2 difference means we can say 2 and 4, because 2 plus 4 equals to 6. So one will be one number will be S and another number will be X. Okay, and remember that. So here we have a 4 and 2, so STYX. So one number in the difference has to be S, another number in the difference has to be X. So which is S and which is X? Always remember, always, mostly for lower boranes like B2H6, B4H10, these things, the some like number of boranes equals to number of BHP bonds for these 2 cases. That means, so number of boranes how many here? 4. That means S will be 4, this will be 2. Okay, for these 2, number of boranes equals to number of BHP bonds. You can calculate in the structure also. If you see the structure of B4H10, so you will be having 4 BHP bonds. Next, this is the step 2. And step 3 is now the difference between number of boranes minus BHP bonds. BHP is nothing but S. That will be comes out to be T value. Okay, T value means BBB bonds. So now what is the number of boranes here? 4 minus BHB 4, that will be 0. Next step 4. So we have to calculate the total number of bonds. So total number of bonds, how you will calculate? So total number of bonds will be number of number of boranes plus number of hydrogens by 2. Okay, so here how many boranes are there? 4. How many hydrogens? 10 by 2. This will be 14 by 2 will be 7. So total bonds are 7. So out of 7, just calculate. Here 4 came, here 2 come, so 6 is over. How many is left? 1 is left. So that will be this one. So if you want to identify the Y number, this is nothing but total number of bonds minus S plus T plus X. If you do this one, you will get it for Y. So this is about the B4 H10. And next we will take B5 H11. So it's better to calculate the total number of bonds initially itself. So we will calculate number of bonds, total number of bonds by 2. So number of boranes equals to 5, number of hydrogens equals to 11 by 2. This is 16 by 2. This will be 8 bonds we will get. Okay, so now step 1. In the step 1, we will take a difference between the number of boranes and hydrogens. NH minus NB. So 11 minus 5 equals to 6. So here number of boranes equals to odd. So now the difference we have to split into 2 odd numbers. 6 means 2 odd number. It can be 1 and 5 or 3 and 3. So but 3 and 3 is the most preferable, because 1 and 5 will not exist, because 5 means this BH2 bonds. 5 BH2 bonds never exist. So this will be 3 and 3. Now S, T, Y, X. So this is 3 and this is 3. So how many over here? 6 bonds over. So we have left with 2 bonds. Now next step 3, we have for T value we have to identify. That will be identified by number of boranes minus number of BHB. That means S value. So number of boranes how many? 5 minus number of S 3. S will be 2. So now we have to identify Y number. So here total how many bonds are over now? 6. 3 plus 3 6 plus 2 8. So total number of bonds are 8. So RLR 8 is over, and Y is nothing but total number of bonds minus S value plus T value plus X. Total number of bonds equals to 8 minus S, T, Y, X together is 8. 0. This is the STYX number for B5 H11. So for now we can calculate for B2 H6 also. That idea I have not done here. And these 3 comes under one set. And whatever now I am going to talk like other boranes, like B6 H10, B10 H14, B5 H9. These comes under another category. Okay, just only small difference, nothing else. So just remember all these things are having 0 BH2 bonds. That means X is 0 for these things. Okay, so now we'll calculate for B6 H10. So step 1, just difference between the number of hydrogens minus number of boranes. This will be 10 minus 6 equals to 4. So now we know we have to divide this one like 4 and 0, because we know that number of BH2 bonds equals 0. Because of that we will keep X value as a 0. Okay, so STYX, this is always 0 for these three. This will be 4. Okay, number of bonds, how many here? 10 plus 6 by 2. This will be 8 bonds. Total 8 bonds will come. Now T value equals to number of borons minus BHB. Number of borons are 6 minus 4 equals to 2. Now Y equals to total number of bonds minus S value plus T value plus X. Total number of borons, how many here? 6 minus total number of bonds 8 minus, so STX together 6 2. So this is the STYX number for B6H10. And next we have B10H14. Here number of hydrogens minus number of borons is equals to number of borons, how many here? 14. Number of hydrogens 14. 14 minus 10 is equals to 4. So here also we know that BH2X value is 0, that will keep it 0, and this will be 4. STYX, this is 4 and this is 0, and T value will be difference between the number of borons minus S value. Number of borons, how many? 10 minus S value equals to 4. This will be 6. And now we calculate the total number of bonds. So total number of bonds, number of borons plus number of hydrogens by 2. So 24 by 2, it will comes out to be 12. Here total how many bonds over? 10 bonds over. So how many left? 2. So this is the STYX number for B10H14. And last we have B5H9. B5H9. So for step 1, the difference between the number of hydrogens minus number of borons, that comes out to be 9 minus 5 equals to 4. Since BH2 bonds is 0, we will keep it as a 0. STYX, this is 4 and this is 0, and T will be number of borons minus S. Number of borons, how many? 5 minus 4 equals to 1, and Y will be total number of bonds minus S plus T plus X. So total number of bonds, how many here? 9 plus 5 by 2. 14 by 2 equals to 7. So here are already 5 bonds over. 7 minus 5 equals to 2. So this is the STYX number for B5H9. Just remember, like B2H6, B4H10, B5H11. So these three comes under one category, and remaining B6H10, B5H9 and B10H14, this comes under another category. And don't get confused between the B5H11 and B5H9. Don't get confusing between these two. Just you remember this one as a lower boranes, these are the higher boranes. Okay, but remember that we have a B5H11, B5H9. In lower boranes, number of hydrogens are more. So here you will get confused. If you get confusion, so that you will lose that mark. So just remember, in the lower boranes we have a B5H11. The number of hydrogens are more in lower boranes, and number of hydrogens are less in a higher boranes. That is equals to 9. Another thing also you can remember that higher boranes, here we have H we have. So higher borane comes, like if you see coding decoding method, it comes to be 8. So 8, you can say 8 plus 1 equals to 9. Like this also you can remember. Okay, H I J K L 9 10 11. So this will be like lower boranes means 11 11 means like 12, coding decoding, sometimes coding decoding will helps to remember this kind of things. So L will be 12. Just remember 12 minus 1 equals to 11. Here 8 plus 1 equals to 9. So like this also you can remember. And next we have carboranes. These are very important. So in carboranes, the calculation of framework electrons is very important. If you want to calculate the framework electrons for carboranes, there is a principle. Okay, that principle like number of carbons into 4 plus number of borons into 3 plus number of hydrogens into 1 minus 2n by 2. This is for the framework electron pair. Skeletal electron pairs. If you know the skeletal electron pair, then only you can calculate you can tell the given compound is either close or nido. Okay. For boranes, if you want for boranes, we have so carborane is nothing but CBNH. These are the units for carboranes, and boranes means only units are BH. So if you want to calculate for the boranes number of skeletal electrons, just remove this because carbon is not part of the boranes. NB into 3 plus NH into 1 minus 2n by 2. Okay, so here n equals to number of borons plus number of carbons. Here n equals to number of borons only. Okay, hydrogen will not come here. And we'll see one example. We have a C2B9 H12 minus. So we have to identify whether it is a closo or nido, arachno or hypoclado. So for that we have to calculate the number of skeletal electron pairs. F by 2 equals to, so number of carbons, how many here? 2 into, here 4 is a valence electrons, 4 plus number of borons, how many here? 9 into 3 valence electrons plus number of hydrogens are 12 into 1 plus here minus 1 is there, that will be plus 1 here, minus 2 into number of borons plus carbons, so 11 by 2. This comes out to be 8 plus 9 3s are 27, sorry 9 3s are 18, sorry 27 plus 12 plus 1, this will be minus 22 by 2, this will be 11. 8 plus 27 plus 12 plus 1 minus 11, 12 27 9 39 plus 1 40 48 48 minus 11, this comes out to be I think somewhere I have done mistake, sorry, this is 22, this 2 is for everything, so I have done mistake. So now is 48 minus 22 will be 26 by 2, this is by 2, so 26 by 2 equals to 30. Okay, so now before calculating whether it's closo or nido, we have to calculate the number of vertices. So number of vertices is nothing but n value. This n value means number of borons plus number of carbons. So here how many borons? 9 plus number of carbons 2, so 11 vertices we have. Okay, so here n plus 1 is equals to closo, n plus 2 will be nido, n plus 3 will be arachno, n plus 4 hypo, n plus 5 clado. So here n equals to number of vertices. Here vertices are 11 and plus number of frame electrons are 2 extra. 11 plus 2 equals to 13. That means it comes under nido. So this is n plus 2 equals to 13. Comes out to be nido. We will see some more examples here. C3, B3, H5. So F by 2 equals to F by 2 means you are calculating the pairs, electrons, F by 2. So here principle is a number of carbons into 4 plus number of boranes into 3 plus number of hydrogens into 1 minus 2n by 2. So number of carbons how many? 3 into 4 plus number of boranes 3 into 3 plus 5 into 1 minus 2 into 3 into 3 by 2. Sorry, n equals to 3 plus 3, it will be 6. So this will be 12 plus 9 plus 5 minus 12 by 2. This get cancelled. 14 by 2 equals to 7. So here n value equals to 6. So this is comes out to be n plus 1 equals to 7 because n equals to 6. This comes out to be close. And next we have C2, B4, H6. In this case 2 into 4 plus 4 into 3 plus 6 into 1 minus 2 into this will be 6. 4 plus 2 equals 6. So this will be 8 plus 12 plus 6 minus 12. This get cancelled. 8 plus 6 will be 14 by 2 is equals to 7. So here number of boranes equals to 4 plus 2 6. So n plus 1 is equals to 7. So this also comes under close. So like this you have to calculate for the carboranes. For boranes we will follow this method. Without this method also, by using this method also we can calculate for boranes. Like we have B2H6. We know this comes under nido. We'll see 2 into 3 plus 6 into 1 minus 2 into 2 by 2. This will be 6 plus 6 minus 4 by 2. 12 minus 4 by 2 equals to 4. Right. So here n equals to 2. So n plus 2 equals to 4. So this comes out to be nido. So for boranes you can calculate by this method also. For carboranes you can do this method, but in all times it will not be correct. Sometimes it may, like when negative charge is there. So this you can write it as a B3 H5. 1 carbon equals to 1 BH. Since 3 carbons are there, we can make it as a B3 H3. So this comes out to be B6 H8. Okay, so this is the closure here, but Bn Hn plus 2. So this is by this method also this is coming as a closure only. But when we have a negative charge, I think that time it will not acceptable, because just imagine one negative charge is there, then it will become B6 H9. So now this is a Bn Hn plus 3. For some carboranes this method is not acceptable, I think. For some so this is the better method to calculate for carboranes, number of framework electrons and whether it's closure or nido. For few things this is acceptable, for few things it's not acceptable. Last year one question was asked in a GATE exam. I think this is the question asked. C2 B9H12 minus. I think we have done this one already. Yeah, this we have done. So this is coming under the nido. So if we do the method which we used to do for boranes, let's see if it's come or not. C2B9H12 minus B9H12 B2H2 and H B11H40 B11H12 14 15. So this is coming B11 H11 plus 4 Bn Hn plus 2 Bn Hn plus 3 Hn plus 4 Bn Hn plus 6. This is coming nido. But I have faced some problem like this kind of carboranes. When I use this formula, so that sometimes I face problem. So for carboranes I think it's better method. So this is about the boranes. Whatever remaining topics left in boranes, I will make another video like borane, borojol, those things. This is also coming under close nido only. CB9H12 B2H2 carbon equals to BH S6 5 plus B2H2 B11H40 plus 1 hydrogen. Okay, I think for some carboranes this method is not acceptable. I am not sure, because earlier I have faced problem when I applied this method for carboranes. You just follow this weights rule. First calculate the number of framework skeletal electron pair, then you just remember these things, so it will be easy. Thank you.